Hello, Professor. This is Julia Schneider, and this is my 7th video correction for Math 130, Survey of Calculus. So I'm super excited because this is my last video, and although these have been very fun, they have taken days, so I am psyched to be finished. This video is going to be concerning learning target I3, which states I can use the fundamental theorem of calculus to evaluate definite integrals. Question 7 asks, question A, B, and C all give definite integrals that we're supposed to evaluate. And yeah, this one down below is correct, but some of these were wrong, and I'm going to get into why. First, I'm going to go over all of the corrected solutions for the ones on the test, and then I'm going to get into my additional examples. So let's get into it. So part A asks us about to evaluate 12 over x to the fourth, d of x, and it asks us to evaluate it at -2 and -1. And the first thing we do, I just wrote that again here for my peace of mind, is find the antiderivative. So I just changed, I took x to the fourth out of the denominator and put it in the numerator by making the power negative. And then to find the antiderivative, it would be, you would do one plus -4, so it'd be -3, and then over that same thing it ends up being. So it would be 12x to the -3rd over -3, and then we evaluate this term at -2 and at -1. So first we have to, and then we subtract the lower one from the upper one, and that is what we did here. We evaluated the terms, and we ended up getting this answer: 4 minus 1/2 equals 3 and 1/2. So yeah, that is our final value. I did not do this right on the test. I was very confused, made it super complicated, brought in an ln out of nowhere. I just got confused. I don't know how, but I thought I saw a 1 over x in there. Just kidding, but I'm not really sure. It was super simple after all, so let's get into the next one. It asks us about 3 to the t plus 2 to the t with respect to dt, and then we evaluate it at 1 and 4. So now we can throw in an ln because this would equal out to 3t over natural log of 3, because 3t, and then you'd get 1 over x and use that rule, or not that rule, sorry, but the natural log rule, and then you subtract 2t squared over 2, and then by taking the antiderivative, and then you evaluate it at 4 and 1. So, and then you subtract the 1 from the 4. So here we have the finished math, and it equals out to 78 over natural log of 3 minus 15. I'm not sure if I'm meant to simplify that more, but my guess is that it's fine like that. And yeah, basically this is just a little note that is just explaining what we're doing, but we're just dividing by the correction over here. And yeah, for C, it says evaluate 2 over t dt, and evaluate it at 1 and 2. And so this one's super simple. I also got it correct on the test, and it was the only one that I got correct on the test. But yeah, this is what's going on. The only thing is, I don't know, I just complicated it here too. And yeah, the general theme is that it's much more simple than I think it is on the test. I don't know why. And so these are just 2 additional examples of the same type of thing. So here we have 2 over x, like square root 2 over x, d to the dnx. Evaluated it at 1 and 8 and subtracted after finding the antiderivative. And that gets you this answer. And additionally, we have one more. Basically just x to the 2/3 with respect to dx, and we evaluate it at 0 and 1, and you know whenever you're gonna plug in 0 to a term, the whole thing is gonna equal 0, most likely if you're using multiplication, and therefore you just subtract 0 as well. So in that case scenario, this is the answer that you are left with. So yeah, these all just demonstrate the same rule but in different ways, and we have a lot of variety in here. But overall, it's pretty simple concept, and I am super happy that this is like one of the ending concepts because I thought it was going to be much more complicated. So yeah, I hope you enjoyed all of these videos. Hopefully they all suffice. Thank you so much for watching, and I will see you soon. And if I don't, because I'm taking my exam in the office, then thank you so much for the most amazing semester ever. Calculus has been a lot of fun, so thank you.